Good morning, everybody. Good morning. I'd like to try and begin close to on time, if we can. Thank you very much. So the first presentation today is by me. So I've been instructed to introduce myself. So I'm Mike Breen from the Institute of Marine Research, and I will be talking about... Can we have the presentation, please? No? So one of our tasks within the platform was to conduct risk assessments. So what I'm going to go through now is what we've done, what influences we've had, and what are the first outcomes of the first risk assessments are, or where we've got to so far. So we set ourselves a task of characterizing the problem, risk assessments, and practical solutions. So the idea was to conduct several risk assessments on several case studies. And we're going to use pathway analysis to define likely hazards at each phase of the fishing operation. And we go through various phases, which I'll talk in more detail later on. We actually had 6 case studies. We got 3 case study species: skipjack tuna, nephrops, and mackerel, and we chose 2 different capture methods for each. Today, we're going to focus on mackerel, and particularly regarding purse seining. So, we start with a pathway analysis. In that, we go through the different phases of the operation. We define what the different phases of the operation are, and then we define what the likely hazards are. And then we move on to a hazard risk matrix, where we start defining severity and likelihood, and I'll go into a lot more detail on that later on. So when we conduct these, the ideal scenario is that we have lots of data, which we can feed into this process, and we have the expertise to discuss it. However, data, catch welfare particularly, is rather scarce. So we're often left with a scenario where we have to guess. We have to base it on what little evidence we have. But that involves expert discussion using the Delphi method. And sometimes, in fact most of the time, we're going to end up with a hybrid. We're going to end up with a data set which is missing some data, but we have some informative information we can pull in. Now, in the ideal situation, that would lead to welfare advice. The Delphi method is most likely going to lead to research recommendations. What do we need to focus our attention on in order to inform the risk assessments in the future? The hybrids will hopefully contribute to both. And we should expect the Delphi to come up with some welfare advice at least. And certainly the ideal scenario will be coming up with research recommendations. And we hope that all of this will feed into our operational welfare indicators and our certification criteria. That's the plan. And that was the plan for the platform and the various steps within the platform. So now we have several problems. The first problem is problem of scale. Numbers and diversity of the species. So in terms of aquatic animals that are harvested per year globally, which we're dealing with 1.1 to 2.2 trillion aquatic animals, that should read. Multiple different taxa. We've got fish, elasmobranchs, decapod crustacea. The list goes on. And we have unwanted bycatch as well within that catch. These animals are captured in most accessible aquatic ecosystems. So there's additional complications on the environment in which you're taking these animals from. And we have 58 officially recognized different fishing gear types, different capture methods. So we have a lot to deal with, potentially. There's also a problem of complexity. Now, one of the standpoints, or one of the objectives within the platform is to ensure that good catch welfare leads to good sustainability. Now, within sustainability, we have 3 pillars. We have environmental, social, and economic. Now, between those 3 pillars, there are going to be trade-offs. If you favor one, it's going to lead to costs in another. Hopefully, there's going to be synergies too. So good welfare will hopefully lead to better prices, but it will involve an initial cost. So there's going to be cost benefits across all pillars, and this needs to be considered whenever we consider a catch welfare implementation. Now, I spoke yesterday about ICES and the new working group. In the workshop just recently, we discussed how we were going to move forward. How can we practically address these problems? And we decided the first step, we're going to need to triage. We're going to need to prioritize the various case studies. And so by triaging, we're going to come up with high, medium, and low priority. The high priority cases are going to involve large numbers of animals, either in the catch or in the bycatch. They may include protected species, endangered, threatened, protected species. We'll be looking for scenarios in which we've got a likelihood of high severity in terms of impact. Lose connection. Sorry about that. And there is likely to be sustainability issues as well. In the medium case, one of those criteria at least should be triggered. And in the low priority, yeah, we're comfortable. You know, the numbers are low, and so. But it doesn't mean that we shouldn't be doing risk assessments, because there might be a valid argument. For example, for certification, you might want to conduct a risk assessment to demonstrate you've got a valid case for a good capture method. Now, what we also decided is, in these cases, probably the best thing to do is focus on, rather than cover the whole capture process, is actually focus on particular phases. The particular phases which you are most concerned about catch welfare and poor catch welfare. So we bring our toolbox of the different types, the different sort of grades of risk assessments we can bring in, and we apply the data and expertise. Now, obviously, ICES will be feeding into that. We've got a large database which can feed in, and then there's a large group of scientists who can provide expertise on, particularly fisheries scientists, but there are also welfare scientists within that community as well as social scientists. Catch Welfare Platform, we're going to be contributing with your expertise. And that's being taken as a given, and ICES is really looking forward to that, building up that relationship between us and them, and how we're going to contribute. There will be other people in the room as well. So we've got the European Partnership on Animal Health and Welfare, that will be providing expertise. We've got the advisory councils. So PELAC, the Pelagic Advisory Council, already has plans to do a risk assessment on herring in trawl. That's already underway, and that will be rolled out early next year. And then we've also got the welfare centres, the welfare research centres, and there's one specifically focused on welfare in aquatic animals. So we'll be referring to them as well. So our case study, Atlantic mackerel. The total catch for Atlantic mackerel is 750,000 tonnes per annum, or was in 2025. That equates to about 2.5 billion individuals caught per annum. But this next year, the quota has been cut, or ICES is recommending the quota is to be cut by 77%. So it has a sustainability issue, which will need to be factored in. And it's a widespread species. It's an important commercial stock. Biologically, it's well researched. We've got because it's commercially important, it's well researched, and we've got several welfare-related studies dating back to the 1980s and more recently that we've been conducting in Norway. So it's a good candidate for a case study. So our pathway analysis, we did that as part of our experts, the pelagic expert group. We went through the process. We defined the different phases, defined 4 different outcomes. An important part of this process was defining duration within those different phases. And there's 2 different durations, the actual duration of the operation, but what's important to us is how likely an individual animal is to experience that particular operation. So if we consider pumping, the pumping can last up to 100 minutes, depending on the size of the catch. But an individual is likely only to experience up to about 2 minutes during its transit through the pump, for example. Now we move on to the matrix. Now, when I first proposed this, as sort of in the catch welfare chapter, it seemed like a sensible idea. My former life as a diving officer, I did this all the time. Very quick process. You can go through an operation, define the hazards, bang, 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 and define risks. Nice and quick. I thought this was going to be really easy. However, I didn't take into account all the different phases that we would define and all the relevant stresses. And when you put them together, we've got 18 different operational phases defined by the expert group and 12 different relevant stresses. That creates quite a big matrix. In fact, it's 216 different cells. And in each one of those cells, we're scoring for severity, likelihood, and duration. We've already scored the duration, but I have to move on to do severity and likelihood. So in putting this together, I generated 90 pages of supporting notes. Yeah. Go on. Okay, we good? Yeah. So I generated 90 pages of supporting notes, just bringing in the relevant literature and why I chose particular values in each cell, just as a reference for myself, so I could go back and question myself, which I did often. Now, in terms of choosing severity, we gave ourselves some guidelines. So depending on what information you have, whether it's mortality information, vitality information, behavior, injuries, we gave ourselves some rough guidelines on what the likely severity level would be, just so there was some consistency in the process. Also, in terms of scoring for uncertainty or confidence in the scores, we had 5 different levels, going from individual anecdotal information right up to multiple published scientific papers, which you can refer to and are directly relevant. So some of the information we're bringing in, some of you will be familiar with this. I've presented it at previous meetings. I'm not going to go into detail about the studies, but we've got controlled experiments where we've crowded mackerel, and we've looked at different metrics, including the mortality of the mackerel. And we can see above 100 kilograms per meter cubed, we start to get a significant mortality. Just put a pin in that. We're going to come back to that. What we also did is we went to sea as part of different projects, and we started measuring welfare indicators within the catch. Lots of different indicators. We had lots of different tools. One of the main ones was our catch monitoring probe, which had a camera on board so we could look at behavior, and we also had an oxygen probe which was measuring oxygen temperature and depth. And this was monitored right throughout the whole capture process. And in that, we can also, from the camera data, we can also qualify how crowded these fish were. So we can see a number of different metrics developing. And so, you know, we could also follow the catch as they were being pumped. So we put one of these probes on the pump itself. And we'd even follow the welfare indicators throughout the handling process as well, and into the RSW tank. And we were looking at all sorts of different vitality scores, as well as some simple physiological metrics as well. Okay, we're going to just focus on 2 metrics at the moment: crowding density and oxygen, dissolved oxygen. And this is from when the probe was deployed in the catch. We're monitoring oxygen and looking at crowding density from what we can see from the camera. And we can see as the operation goes on, the fish get more crowded. It's not a surprise. And as they get more crowded, we get a drop in dissolved oxygen as they use that limited oxygen that's available. And if we focus on one particular phase, so in this particular case, this was the pre-pumping crowding phase, so before the pump's actually in the water, and we can see there's a lot going on. We've got a drop in oxygen level, and we've got high crowding density. So how did I score that? Here's some images from the camera in different positions. And so, looking at the crowding, we know from that data, we know that we've got greater than 80 kilograms per meter cubed, which scores at 304. And in terms of, we don't know, we can't tell from that data what that distribution of the likelihood is. So, what I scored was, well, it's 304, and all I can do is split evenly between the two. I've got no other information. So, and this data is not published. This is just in a grey literature report. We haven't published that work here. So it gets a score of 3 because it's unpublished work, and it gets a score of 2 in terms of likelihoods because really not sure about it. In terms of hypoxia, 2 out of the 24 catches we had mild hypoxia events. No severe hypoxia events, just mild. So less than 6 milligrams per litre. And it was only 2 out of 24. So in this, we've got a hard ceiling. We know it can only be up to severity 1. And this work has been published. It's related to several works, both the control studies and the work we monitored in the field, which has also been published. And we've got likelihoods 3, because it's still a bit sketchy, because the numbers are, N is not very high. N of 24 is not very convincing. We've also got, in the pumping phase, this was a nice example. I brought this in because this came from Hannah Digger's work in Syntef. They looked at pumping, and they looked at damage in pumping under different operations. But from that, from the information they provided, I could calculate what the crowding density in the pump was, which was useful. So from that, we know we've got crowding densities over 100 kilograms per meter cubed, so potentially fatal. So that I could bring in, but I'm really not sure how this should be split. We know it's over 100 kilograms, so it's 3 or 4 again. It's been published. It's been published with several publications, but really uncertain about the likelihood again. With barotrauma, they looked at barotrauma injuries. They recorded them, but at a rather coarse level. So they were just saying gill discoloration, which is actually gill hemorrhages. So we know that's severe, and they just reported between 0 and 91%, which really is not, yeah, we need a bit more precision than that. So I just said, well, it's at least half the animals are likely to be experienced as something that's really bad. And then I really don't know where the rest is. So one publication, yeah, I'm confident on severity, but I really don't know about likelihood. So that's how the process went on. You can see it was rather taxing. So what do we do with these scores? Well, the first thing we do is we multiply. We have a level for severity, and here this is just linear. So with a maximum of 10, we've got a straight line going up to 10 with a step. You could argue that these should be lower. They should be given a lower priority, but that's for a future debate. I've just given a linear scale. And so we take the probabilities, we multiply them. That gives us an N value, a risk score for each severity, and then we just sum that up for the whole scenario, which gives us a value. Don't put too much weight in that value. Okay, these are just relative to compare between different cells. What we can also do, we know that different durations of operations, so the longer the animal is exposed to a particular stressor, the more likely it's going to be impacted. So we should factor that in. So we can come up with another measure, which is welfare risk minutes. So we've got welfare risk score, which is just hazard times likelihood, and we've got welfare risk minutes. So this is what it produces. Okay, we've called it a heat map. It's a little chaotic, looking like this, but you can see there's definitely areas of concern. And when I was going through the process, actually, what I realized is it's very important the order in which you consider the different metrics, or the different hazards, the different stresses. Some of them are inputs, so it's just a change of an environmental conditions. But some of them, like, for example, hypoxia, they're emerging because of the crowding. The animal has been crowded, and that leads to hypoxia. So you've also got emergent hazards as well. And it's important how you relate them to each other and how we define them. And that's for future conversation. You can see from this, the worst stage was entering the RSW tank. We could go into detail of why. I'm not going to now. And that's very interesting. We can identify what the worst stage was. And we can also identify, thank you, we can also identify what the worst hazard or stressor is. And here I've now listed them in decreasing order. So we can see crowding is by far the worst hazard, and then activity fatigue followed by hypoxia. And that's also informative. That gives us prioritization of what we should be considering as well in terms of mitigation. So that's informative. But don't take too much attention to the actual values. They have no real meaning, okay? But by using it to list and prioritize, that's meaningful. We can also have an end value, so the total score at the end. Now, how could we use this? Well, we can compare between different scenarios or different outcomes. So here we have slaughter in the tank, and then what happened if the animal escaped? So that was another output. What happened if the animal was released during slipping? Or what happened to the animal if it escaped through a hole or before the purse was fully closed? And we can consider the different stresses or the different welfare risk scores at each of those outcomes. That's interesting. And we can see, obviously, it looks like slaughter in the RSW tank is by far the worst. That would sort of make sense. However, when you bring minutes into the equation, you suddenly change the situation quite dramatically. And so slaughter in the RSW tank is completely outshone by the escaping catch after a burst net. Now, as you imagine burst nets, they normally burst when you're crowding during a pumping operation. So if the net bursts during that phase, the animal's been crowded and the net is burst because it's been overcrowded. You've had some considerable force on that to burst it. So that's not a good scenario. And so that sort of makes sense. And the animals could be exposed for some considerable time before the net bursts. So that sort of makes sense. That's essentially what happens. It's because of the crowding phase and the length of that crowding phase that has such an influence. There's another way of looking at this as well. We can see that these phases are by far the worst during the whole operation. So it's the handling and slaughter which is the worst. So what could we do? Could we have interventions? Could we actually step in at some point, for example, by stunning the animals and actually reduce the stressors? So here we look at 4 different scenarios. So this is going in the tank. So stunned going into the RSW tank. Stunned in the dewatering grid. Stunned in the pump. Or just compared to slaughter in the RSW tank, as is the standard scenario now. And again, we see that seems to be some sensible pattern. If you stun it with the pump, all the stresses afterwards have been eliminated. And so that seems to make some sense. But again, when you include minutes in the scenario, it gives us a different perspective on it. Stunning before going into the tank is still always preferred, but actually there's not a big difference in choices between. It's still preferential to stun them in the pump, but it doesn't make that much of a difference. Why? Well, again, it's back to pumping them on board. If you look at the actual scores, the scores are all high here. But because of the minutes, 52.5 minutes on average, then that really inflates that value. Much higher compared to the short periods in the rest of the handling phase. So it dominates the whole situation. So, where does that leave us? We have another map as well, another heat map, which is our confidence scores. And this, I actually think, is one of the most useful outputs from the whole scenario. Because all of these red areas, we know nothing about. That was just my opinion. That's just what I think. What I think just really isn't good enough. We should actually be doing some research into those areas. Maybe, if we think it's a high enough priority. But we can see, and this is in order of the worst stressors,
we can see we've got some worryingly red areas here, and also some yellow and even brown areas where we've got no confidence in that data. So that becomes an obvious focus for our future research. Okay, lessons learned. This was a time-consuming process. It was nowhere near as quick and dirty as I thought it was going to be. Thank you, it's perfect. And it was stressful. It really was individually stressful. I was constantly going back to the tables, comparing different cells with each other, and saying, am I being consistent here? So you've got to think of the welfare of the assessor as well. So it really should be a team effort, particularly when there's low certainty in particular cells. It's very important to have clear definitions. That was helpful. When I had the definitions sorted, that was informative. So those definitions include operational phases and durations, and the relevant stresses, and particularly considering whether they're input or emergent. That is important. And also welfare thresholds. That was a particularly useful guideline. But we discussed in the workshop that they need to be tightened up as well and expanded. The assessment order, as I discussed, is important. And one thing, I ended up going through the process twice. I ended up considering individual hazards, stressors first, and then reviewing it by going through it by phase. And that allowed me to bring in interactions and realize the cumulative effect of these different stressors. And that's important. Now, the other lessons learned is models are only as good as the data used to create them. And this risk assessment, the matrix is just a model. It's producing a number at the end, which, as I said, I'm not going to stress this too much, it really is just, the scores are just relative values. They're not absolute scores. So it reduces the comparability. So what I'm going to warn against now is we shouldn't be comparing between different capture methods using this, for example, because that would be comparing apples with oranges. Because you've got different phases, you're going to be scoring it in different ways. So we have to be careful how we roll this out. But it's useful within a particular operation. Now, welfare risk, I found very useful for identifying where we had high-risk stresses and phases. You can really focus in. It's not clouded by duration. You can really focus in what the key areas are. But then when you want to start comparing scenarios, you do need to start considering the minutes and the duration. So we've got two different tools there, but they should never be considered in isolation. You should always compare them next to each other to understand what impact that duration is having. And then one of the most important outputs is identifying knowledge gaps and weaknesses. So where do we go next? Well, I've already been discussing with some members of the pelagic core group about meeting in January. And we're going to have at least a day-long meeting. It'll be online, but we'll be having at least a day-long meeting. And I'll present the data that I used in this. We'll go through, and we'll go through the supporting notes on how I scored in more detail than I've done now, but in a similar process. And then what I want the group to do is go through the Delphi process. I want some reassurance that I wasn't just making things up. So they then go away, individually score, and we bring those scores together and look at the variation in those scores and say, okay, yeah, if there's a huge variation, okay, we've got a problem. But if they're all reasonably close, then we've got some confidence in stepping forward. So, yeah. Now, then we're going to repeat and roll out for the other case studies. Now here, we're going to need volunteers to collate the data and present it to the core groups. Not necessarily do the scoring, but collate the data, collate relevant data, and then present that to the core groups. And then there'll be a meeting, it'll be discussed, and then people will go away and score. And maybe as an initial round, we should delegate the scoring tasks. So maybe split up different phases or different stressors to individual people. And say, you focus on that, and we'll bring it all together, we'll discuss it again, and then we'll do a Delphi score. And then what I'm also going to be doing is next year, the lessons learned from this and any reviews that we can do in the meantime, we'll take forward into the new ICES working group. Roll that out and try and work on these methodologies and see how we can bring those into alignment. Thank you very much. And that's it. That's the plan. Okay, so if you've got any questions, please just shout out now.
Fausta.
Thank you so much, Mike. Really impressing. I am a little worried about one thing, that we combine our effort. As you know, we have the Fairfish database, which is doing pretty the same or very similar things. And I missed the name in your presentation. Really missed it. And I think that especially Jenny and now Vignesh are doing a great job of to score the welfare in the different catch phases, and they do really practical the same work. I'm not sure it is not 100% the same, but it is very, 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 very similar. And also we did in the catch welfare and the Catfish Catch project, we did all these risk assessments, and you have the 3 posters outside where there is a matrix of risk and also 2 posters with recommendations. So I really beg you to combine our works so that we don't waste human power. Thank you.
Yeah, well, thank you for correcting me on that. That work wasn't ignored. So the database, the data used in your database, I gave to Jenny, right? So the lit search for that was essentially based on what I've included here. But you're quite right, and what I can do, I'll include that logo in that. So in that IC's. No, I know, but the thing is that data has been used, and you're absolutely correct. You're absolutely correct, and I'll make sure that that becomes part of, is recognised within the protocol. So thank you for the correction, much appreciated.
Hi, Mike.
Hi,
obviously, great work. You know,
Thank you.
it's really impressive work, and I think this is going places. Regarding the minutes that you incorporated in the risk assessment, I don't know if you're familiar with the Welfare Footprint, the Welfare Footprint Institute framework to assess, to quantify, in this case, pain. But I think it can be extrapolated in this case because they specifically include the duration and the severity, in this case of pain. But I think the framework, the way they calculate this can be very useful for this. They've done this for fish, in this case farmed fish, but I think it can be really useful for this, for your framework, for your risk assessment.
I'm familiar with the framework, yes. I haven't deliberately incorporated in this, but what we will do, we will certainly consider it within the working group. So absolutely, all of those inputs should be considered and discussed.
And another detail is the European Reference Center that you mentioned. Being sort of involved in the reference center, I addressed Michalis and Cito about fisheries. And they were a bit skeptical because the scope of the reference center is towards competent authorities, and the competent authorities at least do not specifically address fisheries. I think it's a really good idea that we should push to include fisheries, but their initial opinion was, no, let's stay away from fisheries at this point. But I don't know if you had further discussions with them. But
yeah, I spoke to Cito about it. And so in terms of what we're doing in fisheries, yes, they said no. Our focus is on aquaculture, but the working group, the ICES working group, is also considering aquaculture. So that's where that reference fits in. I've basically stolen a slide that's being presented as part of the ICES working group. So, but yeah, you're quite right. But I also think, and we've discussed this before, there's a lot we can learn from the work that's been done in aquaculture, and that absolutely should not be ignored. So I want to maintain that connectivity or develop it, and I think the reference centre should have an input here as well.
Yeah, and about the Welfare Footprint project, we had 2 meetings to compare our methodologies, but it was not matching enough to simply, and they were coming, but they were not able to attend today. Any other questions?
Yeah, thank you. Very interesting presentation. My name is Ludwig Zanskowski. I am interested to get an estimation from your side. When do you think we will get verifiable parameters ready for an audit process? You know, certification processes are important in seafood trade and retailers are looking for it. So what is your assessment?
Realistically?
Yeah.
Bearing in mind that this isn't our only job, I mean, I would hope by the end of next year, the case studies that we have within the platform will be rolled out completely to some degree. Right? So we've got more data in some than others. So some of those assessments will be predominantly just Delphi method. And that may be just a quicker process, but our target will be the end of the year, if not before, but realistically.
So they're part of our working objectives as well. Yep.
Hi, Mike. Yes, very interesting. I'm just thinking that I'm not sure if you've looked at. I think this footprint was inspired on the Sharp and Sanders paper originally, where they were doing this type of assessments for pest control. So there is the two phases. One is if the animals don't die, and another one is when they die. So I think a lot of the things that they use, and it's very simple, can be incorporated into this one assessment, because you have the 5 dimensions involved. So then you can score for the 5 dimensions within the different processes. Okay, so I think that would probably be maybe more complete, but also simple.
Yeah.
So you have a really easy scoring system, and also a heat map that tells you each of the different systems, how, you know, welfare risk and its intensity and time as well involved into the assessment. So it probably can help a little bit to kind of refine a little the...
Yeah, well, as I said to Yao, certainly as part of the process, we're going to, what I'm doing within the platform is going to reflect what's going to be done within the working group. And so, and that working group will be used to refine the methods.
Yeah.
And try and provide some standardization for anybody who's going to be applying these methods. Yeah. That will become part of that discussion.
Mm-hmm. Yeah, because you come up with a number, but it's just a 1, 0, 2, 3, and a number and a letter, and it's just very visual, very simple, because for certification or, you know, auditing, all these things, it can be very helpful. Mm-hmm. And also you're not incorporating a lot of the dimensions like behavioral dimensions, the mental state of the animals, all these type of things that need to be either investigated further or incorporated later for the proper assessment of welfare, because most times what we do when we assess welfare is just looking at production. We're not assessing all the operations, but not really the individual welfare of the animals. You know.
No, thank you. It will certainly be considered. Klaus.
Yeah, thank you for the talk, Mike. It was really a great talk.
Thank you.
My name is Klaus Sparboen, and I work for the pelagic industry in Denmark, the catching industry. And we've also been looking into catch welfare for a couple of years now, also together with PFA, which Lina was giving the presentation yesterday. And one of the lessons we have learned is that there is a huge variability between hauls and between trips and between whether you fish, for example, herring in the summer, in the winter, and you could also see that from the presentation yesterday from Lina. And I'm just a little worried how that sort of variability is going to be captured in this process here, that we don't end up drawing some conclusions on a few trips on certain conditions and then say that is a risk assessment. So I'm just thinking, how do you have any thoughts on how you are going to sort of include that uncertainty, which, at least in our experience, is quite large?
Yeah, well, that would be reflected in that confidence score. So if we think a particular phase is very variable, and that the data we have is not properly describing it, then that will be reflected in the confidence score. So it'll be given, probably, I would imagine, I don't know, we haven't had that discussion yet, and you will be involved in that discussion, being a member of the core group. I would suspect we'd probably go for, okay, what's the maximum? We may look at 2 scenarios, maximum severity and what we think is a median, and then see what impact that's having. And then just say, but we're not confident here. This needs more research. I would suspect that would be the result of the conversation, but we haven't had it yet, so I don't know.
Hello? Yeah. So for the people, there are quite some people who are new to the platform, but just to inform you, these risk assessments are being done with the help of our members from the industry. They deliver the input for these risk assessments, so that's important to know. I think we go to the next talk.
Yeah, I think if there are any more questions, just grab me at lunchtime, okay? Yes. Thank you very much for your attention.